Kia ora, hello again. I ought to start saying that, this isn't the show according to Sam Archer. It was meant to be my colleague Joe Quad taking this session, but he's gone and got himself COVID. So there we go. All right, so the next panel session, as was introduced very well by Rui, is going to be on embodied carbon. So this is a sort of interesting topic now, isn't it? That I'm sure this is a sort of old story, isn't it? That for a long time the green building movement was really focused on operational, the way in which we run our buildings and the carbon associated with that. And then slowly over the last really 10 years, we've started to realize the importance of the environmental impact of the products and materials that go into the building in the first place. We would argue, actually, in Aotearoa, it's sort of, in a way, proportionally more important because we have a clean grid. That grid is getting cleaner. We are promoting very much the idea of electrifying our buildings. So, we feel like we've got a clear pathway to decarbonize the operation of our buildings, but the emissions associated up with making the products and materials is the tough nut to crack, and the one that we have personally, NZGBC has been doing a lot of work on for the past 2 or 3 years. We released a report, or probably 3 or 4 years now, on that thinkstep did for us, which looked at the hard numbers in terms of the proportions. And actually, in Aotearoa, roughly in a given year, half of the building sector emissions come from how we operate our buildings, and about half from the manufacture of the products and materials. So it's a really important part of what we do. Okay, and so life cycle analysis and a subset of that, embodied carbon analysis of buildings, is increasing in practice in New Zealand. It was made compulsory in Green Star in the latest version that we launched a couple of years ago, version 1.1, and we're seeing very much the larger consultancies doing more and more of this embodied carbon analysis. Some fantastic architects practices in particular are really championing that and doing it on most of their projects. I also want to declare that I'm on the board of EPD Australasia, so Environmental Product Declarations, and we're seeing, I would say, the majority of the larger products and material suppliers in New Zealand really getting on board with getting EPDs, like nutrition labels, for their products, which is really, really great to see that those numbers are increasing exponentially, which is really, really fantastic. So, we're very much now, I think, on that plateau of engineers and architects' practices and building professionals knowing how to measure embodied emissions. The next stage is really about, how we reduce. So, to that end, when we worked on the newest version of Green Star, which was launched last night, Green Star Buildings, we employed Beca to write us a report, which we will be publishing shortly, which was really looking at what does the science tell us we need to do in terms of emissions reductions from that embodied carbon sector. And the conclusion that came back is that the sector really needs to reduce embodied emissions by over 50% by 2030, right? So we've got 6 years or so to have a really quite radical reduction in the emissions from those products and materials. So it's a big challenge, and I'm really sort of interested to see what our participants in today's panel have to say about how we're going to meet that challenge. But in wrap up, we really need designers, products and material suppliers, developers, contractors, and building owners to be getting on board with this topic. All right, so without further ado, I'm going to introduce the panelists for this morning. So first up, Phoebe Moses, if you could come to the stage, please. Phoebe has probably, I think, the best title of any person I've ever met, which is she's the carbon navigator at Beca. And Phoebe is she's the team lead for the Beca Sustainable Buildings team in Auckland, a chartered structural engineer. She provides targeted and nuanced low-carbon design solutions for clients in the built environment. Okay, next up, if you could come to the stage, please, Jeff Vickers. I'm sure he's very well known to the sector. I was coming that way, fantastic. Jeff is a life cycle assessment certified practitioner, a verifier of environmental product declarations that I was mentioning earlier on. He holds a PhD in environmental engineering and is currently a technical director of thinkstep-anz. And then last up, where is he? We've got Callum from Naylor Love. He's the leader of Naylor Love's Auckland Regional Sustainability Committee, passionate about reducing the negative impacts of construction on the environment, and he's delivered a number of high-level finished buildings, particularly AUT projects, which have won multiple architectural awards. If you give all of them a big welcome, please. Fantastic. Right. Okay, so I'm going to start off by asking a few questions of my own, and then I think I understand there might be a bit of a roving mic. So if any of you out in the audience have got some questions, then we'll ask you to put your hand up in a minute, and I'm sure you'll have some very interesting questions to ask the panelists. Okay, right. So I think we'll start off with one for you, Phoebe. Embodied carbon is often seen as primarily a structural issue, but what are some of the other key building elements that we should be looking to reduce embodied emissions in?
Kia ora, Sam. Kia ora koutou. Thanks for having me on the panel. So first off, I should say that I do believe that structural engineers do have the biggest influence over embodied carbon.
Of course.
So this is not at all to minimise their impact, but increasingly we're seeing that the understanding of the impact of both building services, cladding and interiors environments is rapidly increasing, and especially for those elements which are replaced multiple times over the building's life cycle. If we're talking about not just emissions now, which are the most important, but emissions in 5, 10, 15 years' time, we need to be putting the scrutiny intensely on those elements and making sure that they are as low impact as possible. But it's quite challenging because it's a bit of a data desert out there for a lot of these things.
Yep.
And often the choices are less flexible and you're more locked into your design decisions on those elements. So I think it's a big challenge for those disciplines.
And then in terms of upfront emissions, so the emissions at the construction stage, as you say, structure is really important. I mean, surely the other one would be facade, right? Choice of facade.
Choice of facade, and not just type of facade, but where your facade materials are coming from, and I know we're going to discuss that probably in detail in the panel. Your procurement decisions are sort of one of the biggest levers that you can have on a project, not just through design, but also being really intentional about where you're getting those materials from.
Fantastic. And then moving on to you, Callum. Thank you very much for joining us on the stage. Talk us through some of the advantages of maybe getting a contractor involved early in trying to reduce the embodied emissions for a building project.
Yeah, I think it's really key to making those early decisions. A lot of the procurement that Phoebe's talking about will take a longer time if we're potentially going offshore with materials. And also by us being able to analyse designs in terms of trying to standardise sheet sizes so that designs are based around standard modules rather than having a lot of waste coming out of those products. And I guess one of the other things we've been focusing on is environmental and design registers. So where we will try and take apart a design and then make suggestions for how it could be, that the embodied carbon could be reduced.
Yep. And as part of that, are we going to start seeing, are we already seeing maybe kind of early stage procurement? So, very early in design saying, well, actually I need this particular product from this particular supplier or whatever, and trying to lock in.
Yeah, certainly. Engineered timber is a good example of that. The procurement model that we follow now is that we will store it in an off-site facility, so we don't use just-in-time like we would with the structural steel trade.
Yep.
So that early engagement probably with both the supplier and the contractor is key to successful delivery of that.
Yeah. Fantastic. And what about existing buildings? This is probably one as well for you, Phoebe. We were mentioning earlier on that existing buildings still make up a big part of our stock, and there's a big movement, isn't there, towards adaptive reuse and so on. But if we are adaptively reusing a building, that's usually a win anyway for doing that. But once you're thinking about adaptively reusing a building, are there certain things that we should be thinking about in terms of embodied emissions?
Yes, certainly. So. Not only, embodied emissions that are already in place are the easy wins, as you say. If you're choosing to retain a building, in 99 cases out of 100, you're going to be reducing your emissions. No matter what level of strengthening or addition you do, generally you'll always be reduced from an equivalent new build. what can be quite challenging and where you can still make further efforts to reduce embodied carbon on those existing buildings. Just because you are getting an easy win from using certain elements or portions of a building doesn't mean you shouldn't really place scrutiny on the further design decisions that you can make and procurement decisions you can make around that. It can get quite challenging because existing buildings are locked in with their layouts and their what's already there. You're working with what's already there, so you are inherently going to be probably less efficient in the new elements that you're designing and installing. Placing a lot of scrutiny, particularly on the structural engineers and architects, to try and work with that existing building in such a way that's going to maximise the efficiency of the materials that you're putting in.
Fantastic, thank you very much. Sorry, last question from me, and then I'll open it up to questions from the audience. This is one for Jeff, really, which is around, I guess, the kind of term that sort of slightly comes to mind sometimes when I think of embodied carbon stuff is Wild West. That for a long time it's been a bit of sort of unregulated, I don't know, there are ISO standards, but we have had that problem, haven't we, that the same building gets 5 different results from 5 different consultants because of kind of lack of consistency around data sets and everything of that nature. What's the solution to that? Well, first of all, do you agree with that? And secondly, what's the solution to that?
Yeah, I'd agree with that. I think I always think back to a presentation that the Green Building Council of Australia gave when they were putting together the Australian version of Green Star buildings, which showed all of the life cycle assessment results over the 200 submissions that had been made to that point, which was back in, I think, 2019. And we had the idea that we could try to set benchmark values, because the goal will be to move away from this reference building approach to be able to set, this many kilograms of carbon dioxide equivalent per square metre of floor area. But when you saw all those results over the last 200 assessments, it was just an absolute, it was junk. It was completely junk. There was no comparability anywhere. You couldn't set any kind of target value. And I think from that that meant that the reference building approach needed to be maintained, but also that data quality drastically needed to improve. And I think one of the things that that we've been working on, with Design and As-Built NZ 1.1, and also now with Green Star Buildings, is trying to standardise the measurement approach. So, how do we account for things like stored biogenic carbon in buildings? Can you allow carbon offsets in the assessment or not? What part of the building do we focus on? If we are doing the whole of life, what are we doing in terms of replacement cycles? How are we modelling end of life? What are the assumptions that we make? And all of those decisions that you make, it can have a massive, massive influence on the result. And the challenge is that it's really, really hard to look at different studies that have been done in isolation and come up with anything meaningful. So I think the key thing for me is just sort of standardising the approach, standardising the underlying data, coming up with something that's internally consistent. This is what's in and this is what's out. Some buildings would account for the fit out, some wouldn't. Some would account for services, some wouldn't. And so you end up with just huge differences in inclusions and exclusions. And so we're really trying to, I think, as part of Green Star, standardise that.
Fantastic. And I guess by extension, I mean, what we do see, don't we, is lots of different, some of the major engineering practices and architects practice, they're using different software, aren't they? And potentially different data sets and different, so we need to find ways. And I guess also building on that, might be worth sort of talking to the audience around the work that Neighbours is doing and the links that has back through to New Zealand as well.
So maybe just a point that's worth keeping in mind is that we do talk to each other on both sides of the Tasman, which I think is a nice thing to have happen.
We try.
So NZGBC, GBCA and Neighbours in Australia are all kind of working together to try and standardise around embodied carbon. So NZGBC's embodied carbon calculated for Green Star actually got effectively gifted to Neighbours as part of an input into their embodied carbon rating tool that they're working on at the moment. That rating tool will be released as like a pilot version from the end of this year. And be more widely rolled out next year. So that's an embodied carbon tool specifically to complement the existing energy tools and waste and other things that they do. And that's primarily in Australia at this stage, so that's not a New Zealand embodied carbon tool, but it will become a pathway under Green Star Buildings Australia, and over time I think it will hopefully make its way this way. But I guess the important point is that there's a high degree of alignment and behind the scenes to ensure that what's happening here in Green Star in New Zealand aligns with Green Star in Australia and also Neighbours in Australia to try to make sure we're doing things in the same way. And so Neighbours has published a default set of emission factors, reference values, and we're actually working on the same thing at the moment right now for Green Star. And so that's something that will come through over time, but there's a strong alignment to try and standardise across Australasia, which I think is really great.
Phoebe, you've got something to say on this topic?
Yes, I was just going to challenge this corridor a little bit, just because what we're talking about currently is the measurement of embodied carbon, and yes, it's really important to get that consistently, but if we're talking about actionable steps, we really need to bring our minds back to, before you've even decided where you're going to build your building. It's those early design discussions, it's those early pre-design discussions that you have that's going to have the biggest impact. And unless you're able to put a carbon lens over those decisions, you're not going to be able to make the right choice from a carbon perspective, or if you do, it'll be completely by accident. So what we're really trying to encourage, as well as the standardised reporting sort of at the end of projects, is democratising the understanding of carbon enough amongst project teams so that people can make informed decisions with that carbon lens. And again, like most of those decisions are being made really early on. Do you build new? Do you demolish? We were hearing from JLL this morning. That's one of the things we want people to be thinking about at that stage. And unless you've got just a base working level of knowledge, to what Miko was even saying this morning around, everyone's got their part to play and everyone's got their sphere of influence. Unless we're sharing, not everyone needs to do an LCA, not everyone needs to have that level of capability, but everyone does need to be able to korero about carbon and have those informed discussions at every stage of the project.
Yeah, that's a great response, Phoebe, and that's a sort of good segue to another question that I wanted to ask you, which is, you get a new client come to Beca and say, look, I'm interested I'm in the early stages of thinking about a building. What is the process you at Beca would take them through, from those early stages through to completion? How would you walk them through that?
Well, I think we're in quite a privileged position, and that because we've done a number of assessments, we have started to see some of these trends coming through, and so understand just where those big carbon impacts typically are and what sort of decisions mean that there will be a significant carbon impact. So just being really upfront about those now. First discussions like, here's a list of things that you want to look at. What's your soil type beneath your building? Where are you building? What's the seismicity? Your structural engineer is your best friend in these discussions. They're going to be helping you get the most efficient building you can. Listen to them. So we will generally try and be really upfront around the biggest impacts. Do some really early optioneering between options. Again, not everyone's going to be able to do carbon numbers themselves necessarily, so we can help them put numbers to some of those options through pre-concept, concept, feso, and really just guide where those decisions happen. Yeah.
Maybe talk to your local friendly builder as well.
And talk to your friendly builder all the time.
Yeah, I think that's key as well, because the moment those decisions are made up front, it's very difficult to change a course. So like we often face it with ECIs, where we come on relatively late in the piece, and if we want to suggest any changes, then it potentially has cost implications in terms of redesign, reconsenting and things like that. So that early involvement's key.
That's great. Right, I'm going to move on to the questions in the... actually, should we do questions in the audience? So who's got the roving mic? Up there. Anyone want to put their hand up?
Thank you. It's Tyrone Hodge again. Just love the sound of my own voice. But I just want to take you back to the data piece, because I think that's really important. And one of the observations that I have is that when you're doing a new build or an upgrade, all the data is available, all the specifications, everyone's really focused on it. Once the building goes into the operational phase and other things happen along the way, I think there's a data governance piece. So I guess I'm interested to know, who do you think in terms of whose role is it to make sure that that data is kept up to date throughout the life cycle of the building, and not just at the construction point, but the ongoing maintenance and governance of that data? Because that's where I think we start to have more problems, is it just gets lost. So if someone says, what's the embodied carbon? You go back to the original specification and say, it was that then, but now we've got new carpet and, who knows what's happened. So whose
What
responsibility?
a challenging question. I think that kind of ties into some of the discussions happening around circularity and material passports as well. And I know that that's, from the suppliers, from the supply industry, it's quite a big discussion they're having, is how to make sure that everyone knows what's in the building at any given time, so that in the future you can look back and say, okay, well, this is what we've got, how can we use it better? I don't have an answer for you, I'm afraid, in terms of whose job it is to manage that. I think facilities managers are already probably overstretched, and data management is, no real answer for you there, I'm afraid, from me.
I might add to that, actually, which is I think a lot of the Green Building Council, Jeff has already mentioned, we and neighbours have decided to sort of base our ratings on the upfront carbon, so the carbon up to practical completion. I guess a lot of our thinking behind that is that we give the rating once the building's finished, but you're quite right, the embodied carbon continues, doesn't it? Because it's about decisions around how often you replace the facades and how often you replace the carpets and things like that. So I do think there's a space in the market somewhere in there for how we control and think about the emissions associated with all that maintenance and replacement and end of life and all that kind of stuff. And I'm not sure we've really, tackled that one yet. Yeah, I don't know, Jeff, I don't know if you've got any views on that.
I mean, I think the point about passports is an important one. I think, there's always been talk about integrating it with BIM and those kinds of things and how you track that through. But it is, the building's being handed through potentially multiple owners and all sorts of things over that time. It's quite difficult to maintain that continuity. And I think that does become practically challenging. I also think there's a bit of a data gap. We've been talking about structure, we've been talking about facade, we've been talking about the big heavy things, which are a little bit easier to get information for. We know that all the fit out contributes an enormous amount of impact, but with the exception of a few materials like carpet, for which there's good data, actually it's a bit of the data desert is very real, and the cumulative effect of fit out is significant, particularly where there's, a retail site and there's significant churn. It might be every 5 years, you're ripping it all out and replacing it again. That's really significant and adds up. But you do have this data desert issue where you've just got very, very little information. And so I think it would be great if it could be maintained through time, but it would be great if it even just existed in the first place to be able to make the calculations to work out, okay, well, what is the significance of this thing? But it's a great point, and I think it's a really tricky one to answer.
Mm-hmm. Right, I'm going to move on to some of the questions from the on the Slido app. This first question is, I'll just put it out there. This does not reflect the opinion of NZGBC. What are some strategies for moving clients and designers away from concrete and steel to lower embodied carbon alternatives?
Yeah, I think there's got to be efficiency in the design. Like we would always suggest when we're going to engineer timber using a hybrid design, so not going for solely timber, which is going to drive up your cost and put complexity into detailing. If we can get to a point where we're doing gravity, engineers supporting gravity loads, and we've got steel or concrete supporting seismic loads. Because what we do see is that a lot of our timber buildings are generally institutional type clients. It's not really the developer. So what we would like to see is that there's kind of acknowledgement of that, simplification of the designs, and then the costs come down relative to that.
That's great. Anyone else?
Add to that and say that I think ultimately, clients are looking for comfort and surety, and that there aren't going to be any major surprises. And one of the main de-risking things you can do is move to a hybrid building, and use different materials where they are best suited and that don't have significant other implications that make things like acoustics or fire or whatever the case may be, 100 times more challenging.
Yeah. I guess, I ought to say, reflect what you think the Green Building Council position on this is, that we need to be kind of agnostic about materials, really. It's not about moving away from concrete and steel. It's about, well, how can we get the lowest carbon building? And sometimes that might involve some concrete and steel, and try and procure lower carbon versions of that. And actually, interestingly, that sort of leads us on to a bit of a segue question, which is, forestry is devastating to Aotearoa's environment, biodiversity and soil water quality erosion, etc. How do you reconcile this with the push to timber and the focus on carbon?
Well, funnily enough, tomorrow I'm actually speaking to the Timber Design Society about timber and carbon and wider things. And as part of that, I realised that, so the Forestry Stewardship Council, FSC, which some of you may be aware is one of the sort of certifications out there for sustainable forestry, they released a guide specific to Aotearoa, New Zealand, that takes into account our landscape and our people. So there's actually like a fourth layer added for Te Ao Māori and requiring Māori engagement, iwi engagement, which is really interesting, recommend a read. To the point in the question, they have introduced a risk identification framework for the type of soil and the landscape that the plantation has been planted in, and requires careful management. So one example is that if you are replanting on a slope that's been nominated as high risk, you're not allowed to plant in a way that requires clear felling. And so there are, for certifications like this, there are ways of managing impact to biodiversity, to soil health, erosion, all of the above. Not to say there aren't massive impacts, but there are growing ways of managing those impacts.
Fantastic. Anyone any other takers?
The point that I would just add to that is just that there's impacts of everything, right? As a person who assesses the environmental impacts of products day to day, there is no free lunch. Everything has an impact. There are trade-offs. And I think we just need to be kind of aware of that, right? We need to manage them as best we can. Those are really good examples. I think it's just nothing is perfect. There is no impact product, and there will be trade-offs that we have to manage, and that is one of them.
Yep. Fantastic. Some more questions from the Slido. This is actually one that I was going to ask, or a similar one, which is that creating and publishing EPDs can be very expensive and time-consuming. This is probably one for you, Jeff. How can we encourage suppliers to work together to share resources and publish product generic EPDs or embodied carbon data? And I guess add to that, to the questions I was going to ask, which is that, do we need to go? I mean, if we're interested in what we focus very much on carbon rather than the full, multi-factor. I mean, do we need to go to full EPDs, or are there other ways that products and material suppliers can give us their carbon data without necessarily going to full? And is that a solution, maybe, for reducing costs?
Yeah, I mean, I think the comment is valid, right? It has there are significant kind of time and cost things associated with producing environmental product declarations. I think part of it has also been just that the market demand has increased dramatically over the last 3 to 4 years. So if you think back, pre kind of COVID, there wasn't vast amounts of demand. There were some initial forward-moving, forward-thinking organisations who were publishing them, and then over a period of about 3 or 4 years, it just went absolutely nuts. Not just in New Zealand, but actually around the world. And so what you had is a situation where the world's life cycle assessment and carbon footprint practitioners got totally stretched beyond recognition, and we couldn't train people fast enough. So I think we do need to recognise that there have been challenges. I think there are some solutions, like there's been a significant increase in the number of tools being developed for producing these kinds of things at scale. Definitely working at the industry association level is a good way of bringing things together, and it's something that we've done for a long time. But it does require a lot more sort of herding the cats. We have to organise everyone to make that happen. Data collection is always something that takes an incredibly long time because everyone's got a different data system, and you need to kind of all pull it together in a way that's coherent, and that's a problem that we're not going to solve immediately. But I think combination of better tools, working together as an industry, and just probably having more people in the market to be able to deliver that, it will be all important kind of parts of that. I think you do see now that there is a significant amount of data on the market. Yes, it's taken us a few years to get there, but now there is actually quite a bit there, and it is growing. I think the challenge that I see mostly is how do you roll it out to the next tier of industry, right? If you look at what's there, it's primarily the big end of town who's been producing EPDs. How do we roll it out to the fabricators, the other sort of downstream assemblers, manufacturers who are taking those materials, adding something to it and doing a bit more, and do that simply and easily? And that's where I think software tools and other things and more automated processes can help.
As you say, Jeff, I mean, a classic one that we hear is from the concrete industry, where they tell us, there are 60 concrete suppliers, give or take, in New Zealand, and 2, 3, 4 of them are the big tier ones that do a lot, and then there's a long tail of very small, and how we get the data from those small concrete suppliers,
Yeah, and it might be that you don't need EPDs for everything, and I think concrete's a great example, right? Because every concrete mix that goes out of a batching plant can be different to the last one, right? Because they're making them on demand. And so that's a case where maybe rating tools could recognise EPD-like data, that isn't actually an EPD, to be able to allow that.
Yep. Very good. Sorry, we only had one question from the audience. Is there any questions out there? Come on, don't be shy. Oh, we've got one at the back here. Scott. Excellent.
I've got a loud enough voice, mate.
That's for sure.
Is there anything that you've found from a carbon saving perspective that's really unintuitive, or was a surprising saving you didn't think you'd get that, or something you changed in the design, you're like, oh, that didn't save us nearly as much as we thought? What are those unintuitive things that might not be sticking in people's heads as an easy win?
I think from a construction side, like waste management is a key one that we focus on. So wherever we can, divert from landfill, or we can engage with suppliers early that they'll take their product back and reuse it. So we certainly get some good gains out of waste management. I think that's probably a key focus area for contractors that we can influence. And similarly with site setups, for us. Like if we can encourage, the use of fossil-free tools, get our power on early, look at, solar power generation for our temporary setups and things like that, then we can certainly provide some good wins through that.
I can say what has been, is consistently surprising to people when we tell them what is standard. People assume that low carbon concrete is going to get you Green Star. And the reality is using low carbon concrete for all your concrete in a project is likely to get you maybe 3% reduction, if you're lucky 4%.
Wow.
And that's, people spend so much of their mental effort on this one topic and they talk about it a lot and they're just like, oh, do we do 20% reduction in concrete or 25%? And you're like, well, let's just keep expanding the conversation beyond concrete. And the other one is that I find people, and including me, it can be quite hard because we measure carbon on a per metre squared GFA metric, but also the total tonnes of carbon is really important. And when you're looking at sort of low carbon typologies, for example, if you have a basement or no basement, removing a basement is really, really impactful from reducing a carbon total generally. But anything that you do in a sort of like one location has to be spread across the whole building GFA. And so you tend to see actually benefits be diluted quite a lot if you're only focusing on one area of the building or one element of the building. So I think people tend to be surprised downward rather than upward at impacts, yeah.
I guess that's related to another question that you've kind of almost answered, Phoebe, but how do we challenge the need to build certain things, and would you do that as Beca, first question, and the second question, I guess I admit this, that that's a green rating tools problem, isn't it? Because we do it per square metre, not in gross terms. I'm not sure how. Maybe you can make some suggestions. Somebody said it should be per person, not per square metre. But anyway, what's your response to that?
Per square metre is the easiest, so let's stick with that. It's also probably the most equitable measure across multiple different building typologies. But in terms of the question around rewarding building less, or do we need to build? I think that it's currently rewarded if you have an existing building on site. So I think in a lot of ways it is, most people develop brownfield sites, and so there generally will be an opportunity to avoid building or procuring materials to some degree. I think this ties in really importantly with the sort of whole national conversation at the moment around earthquake-prone buildings and seismically deficient buildings. Structural engineers are a massive piece of this. And if we look at the scale of buildings across the country that, are subject to seismic risk because of their level of performance and their location and their type, if we can retain all of those buildings, the scale of impact is massive. Unfortunately, most of them are small buildings and won't be eligible for Green Star necessarily. But I think it will be rewarded through building reuse. But it's a hard conversation because where do you draw the line? How do you justify that you genuinely didn't build, or maybe you just couldn't afford to build?
Yep.
Yeah.
Yep.
I think just on that as well, like our role as contractors, and maybe designers don't like it, is not necessarily challenging the need to build, but what we're actually building in terms of a structural design. A lot of them feel very risk averse, and there can be methods, for example, like if we're grooving piles, which we've suggested on some jobs, and then there's less socketing into rock, so you're reducing your concrete content. So I think as contractors, it's our role to continue to challenge those designs as well.
That's great. Yeah, that's great. Okay, so the top voted question at the moment is sort of back to that subject of the ongoing embodied emissions. So how do we ensure we're getting design for maintenance, longevity, waste, and other environmental and social endpoints which are not currently very well proxied by current carbon accounting standards?
I think, obviously designing for maintenance, designing for disassembly, designing for repair, all those things are really, really important. I think the challenge that I see when you're looking at that from a structural perspective, like we often get asked questions, should we be designing reusable steel structural systems or reusable timber structural systems? I think the challenge with that is that the time horizon you're talking about is so long, it's very hard to forecast a need 50 to 100 years from now and know what the future buildings might look like. But I do see huge opportunities to move into the fit-out space where the churn rate is much, much higher, to look at reuse and how we measure things at that level, and then looking at what we could do to really optimize that area. So I think potentially a step could be, let's try and get the big heavy stuff right first, and then maybe in a few years, or as soon as we can, let's look at trying to sort of solve this kind of fit-out issue. Where there is more churn and there is more opportunity to kind of do more.
I ought to mention that Green Building Council of Australia is currently working on the next iteration of their Green Star fit-outs tool, and as I understand it, they're going to put a real focus on circularity and on kind of the embodied emissions of that kind of churn of fit-out, because it's really big, isn't it?
I also recommend, and I know there's a lot of costers in the room, and they'll be like, yes, cost can often be a proxy or at least a guide to carbon impact, and if you've got good cost data around where you're spending on maintenance and replacement and upgrades and all of that, look at the big cost buckets, and that will generally be where your big carbon impacts are as well. Not always, like there are exceptions, but yeah, there is that data, and we can use that data in a way that's meaningful for carbon as well.
Yep, excellent. Somebody's waving at the back here. We've got a question at the back.
Thank you. As we get the Building for Climate Change guidelines more solidified, are we potentially running into a bottleneck of professionals that can carry out LCA analysis? Will they all need to be accredited by LCANZ, and are we potentially running into trouble there?
I guess my view would be that that's why the tools are so important, because the answer to your question from my perspective is no, they wouldn't need to be. That it would be ideally the building professionals themselves who know what the materials going in are, who are the ones who are entering this information. We've seen huge uptake of this kind of work from the likes of quantity surveyors, architects, people for whom it kind of naturally fits into. Obviously, you've got your structural engineers, others as well that you can talk to. But I think for me, a big part of building all of this, for building the tools, building the databases, is to be able to hand that over to other people to implement, because if we do try and roll that out to life cycle assessment accredited professionals, well, the pool is very small and the training time is very long. So no, I don't think that's going to happen, but if we can get the tools right, then I think we'll hopefully solve that problem.
Are those professionals more suited to the kind of producing the EPDs in the first place, that kind of thing?
Yeah, I'd probably see the role of LCA professionals more in the product space, more in helping with the methodology of how these tools are rolled out, but less so in the doing at the building level, because there are just so many buildings, right? We're just never going to be able to scale enough.
I agree.
Very good. Right, question from the front.
Yeah, thanks. Just a quick question. There's been a bit of conversation over this morning around 1.5 degrees alignment with all those sorts of targets and those sorts of elements. For our particular sector in the embodied carbon space, do we have any sense of what our targets need to be to sort of be aligned in that area?
Yeah, I can answer that one. I mean, so Beca's done some fantastic work for us, and it's looking like if we're going to be science aligned as a country, that we need to be reducing those embodied emissions, upfront emissions actually, by around 50% over the next 6-7 years. So huge reductions, and and you'll have seen earlier on I presented those slides on the Climate Commission and their monitoring report and how we're doing, and they included the construction sector. Really annoyingly, they didn't include embodied emissions in that reporting, and that's because the emissions from that are bucketed into the industrial kind of sector of the kind of government level reporting. But I think we'll put some pressure on them to report on the embodied emissions as part of that building sector as well, because I think we need to see how we're progressing on that. Yeah.
I think the really challenging thing, right, is that that's 50+% for all buildings in New Zealand, not for the best buildings, not the 6-star, 5-star ones, And so I think it's a huge challenge. We need to do a lot in a very short space of time. It's going to be very, very difficult to achieve, so we will need to work together.
I mean, one thing I'll say about that is that, if we as Green Building Council and our rating tools persuade the suppliers to decarbonise what they do, they supply other people that are not just doing Green Star buildings. So I think we as a kind of, I suppose, top tier in terms of green buildings can put the pressure on the rest of the industry to do the right thing.
Yeah, I'll just add that the report does, I'm not sure if you're releasing it, the feasibility studies that, it is possible to do that with today's technology, so we can be quite hopeful that in 6 years' time, the supply chain will be able to support those outcomes, not easily. It would still require a lot of effort on the part of designers and clients commitment to procure those lower carbon materials, but it is within the realm of possibility. So it's not a pie in the sky. But I think those numbers, those targets have also been set, using a fair number of assumptions around how much carbon are we entitled to as a nation or a sector, and what value judgments are we making to say how much we're entitled to. And those are quite hard conversations, not just here, but in the whole conversation around setting 1.5 degree curves for nations, for nations' NDCs to the Paris Agreement. How much carbon are we owed, or in terms of that burden of responsibility, and that's quite a challenge to take on. So we are taking on quite a challenge as the property sector to say we think we owe this much responsibility, and it's quite a good target.
And Sam, that building's being built in 2030.
Yes, that's right. Yeah. That's right. Yeah. And what that means is that we need to each year, we can't just do nothing and then in 2030 suddenly be halving our emissions. It needs to come down over time to have an overall budget for the time. That's right. Fantastic. Well, thank you very much to the panelists. I think we're just running out of time. Thank you very much for your excellent questions, and we'll move on to the next panel.
Just want to stay with me?
Yeah, yep.
Awesome. Ngā mihi nui mahana, a warm thank you for the great panel session, bro. I reckon that was, I'm really inspired, personally, to be honest. These are a couple of my key sort of takeaways, bro. Where you started when you first said the building sector needs to reduce our emissions by 50% by 2030. That's massive, eh? That's a big target. Another one is the biggest environmental impact that we can make, or that you can make, comes from the decision before the project and at the design stages. Eh? The earlier, the better. That was super cool. Number 3, being intentional of where you get your materials from and designing the end of life into the start of the project has a huge impact. Pro tip. And my last pro tip is renovating 99% of the times will always significantly reduce carbon's a lot better, eh?
Absolutely.
That's another really awesome insight too. But Sam, I'd love to hear from you, bro. Like from your kōrero with the panelists, bro, what is your top actionable tip for our audience today?
I think a really good one was Phoebe's point there around, and we're a bit guilty of it, that we want to standardize and have these very sort of complicated official kind of end of project calculations of the emissions. But actually, if we all get more carbon literate, then especially as clients, I think developing buildings and being able to have those early kōrero, as Phoebe put it, around the table on, where do we start? And so getting that carbon literacy, I think that's the great first step.
Yeah, beautiful. Well, tēnā koe, bro. Thank you for hosting that session, eh?
Pleasure.
You coming out for the third time? No. No, okay.